This is a video on multiplying fractions. In a lot of ways, multiplying fractions and dividing fractions is a lot easier than adding and subtracting fractions. The usual rule with multiplying fractions is that you simply multiply across. So let's say I have 3/4, and I'm going to multiply that by, let's say, 5/8. All I do is multiply the numerators together. So 3 times 5 is 15, and 4 times 8 is 32. And that's my answer, unless I can reduce that. And I can't think of anything I can reduce that by. And so my answer is 15/32. I'm going to do another one here. Let's say I have 3/4 and I'm multiplying it by 2/3. I could just multiply across and I would get 6/12, and then I would have to reduce that, and I could reduce that to 1/2. But I can also do something called cross canceling here. I can basically, if I have common factors above and below, I can uh, cancel those factors. So basically, 3 goes into 3 once, and 3 goes into 3 once, and 2 goes into 2 once, 2 goes into 4 twice. Now I multiply across, and I get 1/2 with no need for to simplify right there. So if I can do that cross canceling, that's always effective. Now, continuing with multiplication, I'm now going to multiply with mixed numbers. So let's say, for example, I have 1/2, and I'm going to multiply that by 3 2/3. The absolute rule with either multiplication or division of fractions is that you must with mixed numbers is that you must first convert the mixed numbers to improper fractions. So again, with multiplication and division with mixed numbers, you must change the mixed numbers to improper fractions. So I'm going to do that here. I can say in this way, I can say 2 times 1 is 2, plus 1 is 3, and I have 3/2. And then for the 3 2/3, I can say 3 times 3. So this right here, 3 times 3 is 9, plus 2 is 11, and I have 11/3. Now, I could just multiply across, and I would have 33/6, which I could reduce further. I do have an opportunity to cross cancel here, and I'm going to take that opportunity. 3 goes into 3 once, 3 goes into 3 once, multiply across, and I have 11 seconds. 11 seconds, there's nothing wrong with it. We know we call that an improper fraction because the numerator is greater than the denominator. Usually if I'm given a problem with mixed numbers, I want to present that answer in mixed numbers too, so I'm going to do that. I can do that by saying 2 goes into 11 5 times with 1 left over, so that's 1/2. And so my answer is 5 1/2. Now I'm going to draw a line here, and then we're going to do some division now. Division of fractions is also pretty easy. With division of fractions, the rule is we multiply by the reciprocal of the second number. So we're going to multiply by the reciprocal. Reciprocal. So, for example, let's say I start with the same one I had, but make a division problem. So if I have 3/4 divided by, my dots don't show up too well. That's divided by, trust me, 3/4 divided by 5/8. What that becomes, it becomes 3/4 times the reciprocal of this second number here. And by the reciprocal of the second number, we basically, informally, we say we flip it. Instead of 5/8, it becomes 8/5. We multiply by the reciprocal or the inverse. So this becomes 8/5. And then we have a multiplication problem, and we just do the multiplication problem as we would do any other multiplication fraction problems. We're going to multiply across. I do have some cross cancelization I can do here. 4 goes into 4 once. 4 goes into 8 twice. And so 3 times 2 is 6. And 1 times 5 is 5. I can also change that to a mixed number if I want. And that is 1 and 1/5. Now, addition or division of mixed numbers is just like multiplication of mixed numbers, in that you have to convert the mixed numbers into improper fractions. You must convert them into improper fractions. And so for now, I'm going to have, let's say, I'll do 2 and 1/2 divided by let's say 1 and 2/3. And so the first thing I'm going to do before I invert anything or anything else, I'm going to change this into improper fractions. So 2 times 2 is 4 plus 1 is 5. So I have 5/2. And then this is going to be again divided by, again, trust me, that's a division. Divided by 3 times 1 is 3 plus 2 is 5. We have 5/3. Now, we need to convert this again into a multiplication problem. So I'm going to go 5/2 times the reciprocal of 3/5, or of 5/3, I mean. The reciprocal of 5/3 is 3/5. So I'm going to go 3 over 5. It's always the second number that I'm inverting, by the way. I multiply cross, doing cross cancelization if I can. 5 goes into 5 once. 5 goes into 5 once. Multiply across, and I get 3/2, or 1 and 1/2. In class, we'll probably do some more complicated problems with variables in them also. But for right now, that will end this lesson.